Hello, this video will cover systems of linear equations, solving them, but by the method of substitution. Okay, all right, here we go. Okay, the sunlight is like really bright, so it's like half and half. All right, here we go. Solving systems of linear equations by the method of substitution. Okay, I'm gonna read this, but really what you're probably gonna like is more of these step. So let me just read it. Okay, this method is straightforward. So it's kind of like in short sentences, paragraph of what all these steps are. Okay, so the method is straightforward. You isolate one line with the desired variable. Then you substitute that expression into the second line or equation, right? Then you clean it up. Okay, clean it up means order of operations, arithmetic, like add, subtract, multiply, so forth. Okay, to solve the other variable, you then substitute that found value into either line and you solve. And then the two values that you have, which we're primarily going to stick with the variables x and y, is your coordinate point, which is your solution, your one solution. Okay, I will do another video that will cover no solutions, which are parallel lines, and infinitely many solutions, which is the same line. That will be a separate video. So for the three examples that I'm going to cover, they're each going to have a solution. So one exact distinct coordinate point that they're going to cross. Okay, so let us practice. All right, so here's the example. We're going to solve the system, and this one is so nice, because it is set up for you, set up for me, and so it's perfect. So step one is set up for us. Okay, I'm going to have the camera go over your steps so that you can copy this. So it says this line equation is set up to substitute. Notice y is isolated, y equal, and then whatever follows. Okay, step one, choose the line variable to isolate. It's done for us. That's us, us. Step two, substitute expression into other line, y equal y, right? Everything is equal to itself. Step three, clean it up, meaning find the value of x. So you're going to solve arithmetic. Step four, using the value that we found for x, our variable. Substitute that number into either line to solve for y. And step five is your solution to this system is x equals a number, y equals a number. So ta-da, put it together, coordinate point xy, right, parenthesis, and that's your coordinate point, which is your solution to the system. And step six is I'm going to bring up Desmos, and we're going to type it into Desmos, and we're going to verify our solution, but we're also going to see the graph. Okay, so yeah, okay, let's move on. Okay, so we're going to solve this system. Here's our two lines. Y equal negative x plus 5. This is in slope-intercept form. And 2x plus 3y is equal to 12. That is in standard form. Okay, so this is super nice, super wonderful, because for step one, it says choose the line and the variable that you want to isolate. And it's done for us because, so look, the first line is isolated with variable y. So it's like perfect. Okay, so what do we mean by that? What we mean by that is that this y is the same letter as that y, right? Y is equal to y, which is right here, step two. Y is equal to y. Every variable, everything is equal to itself. So I have first line is isolated y. Second line is what I'm going to substitute into. So I'm going to take this expression and I'm going to put it right here. Okay, so step 2 says substitute the expression. Remember, this is an equation. Y equal is an equation. But we're going to substitute the expression. So what's the difference? You know, here I'm telling you this is an equation, but now I'm saying expression. Yes, this is your variable. This is an equal sign. This entire thing is an expression. However, whoops, my expression is this, negative x plus 5, meaning I'm not taking the y with it and I'm not taking the equal sign with it. So my expression is negative x plus 5. So it says step 2, substitute the expression into the other line. So since it's y is equal to y, I'm going to, instead of this y, I'm going to substitute negative x plus 5 into this variable spot. Okay, so step 3 says clean it up, which means we first have to substitute. Okay, so what does it look like? I'm going to write down here, because if you look at the paper, see how because I wrote all these steps, it's really squishy. So I'm going to come right down here. Okay, so if I'm kind of dropping low, it's on the same sheet of paper. So I'll come up so you can see just how it looks, okay? Okay, so I'm going to take this 2x plus 3y is equal to 12, and I'm going to copy it here so that you understand what it is I'm doing. Okay, so 2x plus 3y is equal to 12. It matches, right? Okay, so with step 2 saying substitute, what that means is 2x plus 3, I'm going to put that expression in place of that y. Remember, y is equal to y. So instead of this y, I am substituting negative x plus 5. So in place of here, I'm putting negative x plus 5 because that's the expression that's bubbled, right? Because y is equal to y. Okay, so I'm going to take that, negative x plus 5, and I'm going to substitute it. Okay, so then the next step says, step 3, oh, let me shift it so I can get in the sunlight. Okay, step 3 says, clean up, find the value of x. Okay, so now I'm going to clean it up. So I have 2x, so I'm going to bring the 2x down, right? Okay, I have a positive 3 with a grouping symbol of parentheses. This is a distributive property, right? So I'm going to put distributive property right here, dp. And so I need to take this positive 3, and I'm going to create an arrow, and I'm going to multiply that positive 3 into the first term. So positive 3 times negative x is negative 3x. And then you're going to take that 3 and you're going to multiply into the second term. And so positive 3 times positive 5 is positive 15. And then I'm going to bring down the equal and the 12. Okay, so what do you do next? Combine like terms. CLT. Combine like terms. Okay, so with that then, you're going to look at this and you're going to see, okay, well, what like terms do I have, right? All right, so when you look at this, this is an x term, this is an x term, this is a constant, and this is a constant. I have an x term and an x term. Those are like terms. Right. Now, here is my equal sign. My equal sign is right here. So combine like terms is not inverse operate. Combine like terms means that when the like terms are on the same side of the equal sign, here's the equal sign. This is the left side. They're both on the left. You honor the sign that you see. So this 2 is positive. This 3 is negative. Hold on, the camera's going to move. I'm going to grab my calculator. Sorry. Okay, so you can do this obviously in your head, but 2 minus 3, 2 minus 3, right? Because I didn't type in the x, gives me -1. So don't do opposites and go, oh, -2, -2. No, the equal sign's over here. You're not jumping the equal sign. So combine like terms means, what's 2 minus 3? -1x. Now, I'm going to write the 1, but you don't have to. So that's -1x. And then I'm going to carry the constant 15 is equal to 12. Okay, so now you're going to inverse operate. Now this is inverse operating, because notice here's my equal sign. The 15 is a constant, the 12 is a constant. However, the two constants, 15 and 12, are being separated by this 11. By this 11, what am I talking about? Is separated by this equal sign. Right? So this equal sign is separating the two. So I need to take this 15 and I need to turn it. It just got really dark in here. Okay, I need to inverse operate it over to the right side of the equal sign. So if this is positive 15, you're going to opposite inverse operate. So what's the opposite of positive 15? Negative 15, negative 15. And so now, what do you get? Well, I'm going to bring down my -1x, or just negative x, it's up to you. All right, this goes to 0, right? And now what's 12 minus 15? -3. Remember, 12 is positive, 15 is negative. So if one number is positive and one is negative, you subtract and keep the sign of the bigger number. So 15 minus 12 is 3. Okay, so is 3 going to be positive or negative? Well, 12 is positive, 15 is negative, 15 is bigger, so it's -3. Okay, all right, and now I'm going to divide. Oh, let me put -15 here, and now I'm going to divide by -1, right? Remember, I want to know what x is, not negative x. And so -1 divided by -1, this you're very good at. Okay, a negative divided by a negative is a positive. And so I get x, oops, sorry, x equal +3. And so that is my first value. Ooh, one-handed. Okay. So that's half my coordinate point. So now if you look at step 3, clean it up, find the value of x. I did that. Okay, so then step 4, using that x number, and it's x equals 3, using that x number, substitute it into either line to solve for y. Okay, so I have x equals 3. So now you're going to choose. So let me just bring an arrow here, and here's what we're going to do. So between these two lines, it doesn't matter which one, because I will give you the same y value. However, y is isolated here. If I'm going to substitute the 3 here, it is straight arithmetic. But if I put the 3 here, I'm going to have to multiply, inverse operate, divide by 3. Like this ends up being a 3-step. This is like a 1-step or mental math. So I'm going to choose the first line, okay? Okay, so let me first write what it is. Y equal -x plus 5. So this is what I choose. Okay, so this is the one I picked. So I choose y equal -x plus 5. Now I'm going to pick, right, that line. So now I'm going to take this x equal 3. Now remember, everything's equal to itself. So this is x and this is x. All you're going to do is substitute that 3 in that place of x, right? Okay, but the x here is positive. This x is negative. So when I plug in the 3, it's only going in for this yellow area. The negative does need to carry down. So I get y equal -3 plus 5, right? And then what do you get? Y is equal to -3 plus 5, which is +2. So y is equal to 2. And so that is your solution to the system. That's it. That's your coordinate point. Okay, I can't do this. Let's write slow. Yeah, one-handed, not so good. Okay. Okay, so then if I go up, it says, oops, in the shade. Okay, step 5, your solution to the system is x equal number, y equal number, and there's my numbers, 3, 2. And so the coordinate point of your solution is this x, y. So remember, the work is up here. I'm just going to come up here, and I'm going to write in this blue, my solution is my coordinate point, 3, 2. And that's the solution. And by the way, there's only one solution, right? Because it has one distinct point. And we're going to graph this on Desmos to show that it is at 3, 2. Okay. The sun is like well, not setting, but it's like so bright in here that the lighting's uneven in here. Okay. Yes. Okay. I know it's 15 minutes, but let me get into the second one. This is going to be a really long video. Okay. And that's just because I have to do 3 examples. So, yikes. Okay, here we go. Second example. Let's get it in the sun. Okay, I'm going to hold it over. There's nothing else written on this paper. I'll pan down, which is where I'll solve, I'll put my work. But the third example is on another sheet of paper. Okay. Okay, solve the system. Now, this example is better because if you notice, both equations are isolated, or both lines are isolated. Notice, x equal, x equal, right? So x is on my left, it's in an equal sign, and then it's my terms. X equal, and then my terms, right? Okay, so this is awesome because both lines have isolated variables, and they happen to be the same variable, x. So I have equal and then blah, 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 whatever's behind it. It works out beautifully for us, right? Okay, so is that good? And these steps are the same. It's just I might have abbreviated them a little bit just because this is now our second time going through it. Okay, because you could always reference back. Okay, so notice x, right? Remember, x is equal to x. Everything is equal to itself. Okay, so this is awesome. Both lines are isolated for us. Okay, step 1 is done for us. Beautiful. Okay, step 2, x is equal to x. So set the expressions equal to each other. So put this 2y plus 8 on the left and put this 5 minus y on the right. Because remember, x is equal to x. And then step 3 is clean it up and solve for x. So I'm going to come down here. But remember, here's x equal to y plus 8. X is equal to 5 minus y. Okay, here, actually, let me hold it just in case you could tell me to pause it because you want to copy it. Okay, so I'm going to start writing because then if you tell me to wait, I'll wait. All right, so let me just copy it so you can see my work at the same time. Okay, here we go. Okay, so we're going to set them equal to each other. X is equal to x. So I'm going to take this one and put it on this side, and I'm going to take this one and I'm going to throw it on the other side. And so what do I get? I'm going to get 2y plus 8 is equal to 5 minus y. And then you're just going to go ahead and solve for y. Oh, it says clean it up, solve for x. Let's solve for y. And here we're going to solve for y. Okay. We're solving for y first. Yes? So the first one went on the left, the second one went on the right. Okay, so here we go. Where is our equal sign? Our equal sign is right here. All right, I have a constant on the left, I have a constant on the right. I'm going to have to inverse operate those. I have a variable y on the left and I have a variable y on the right. I'm going to have to inverse operate those. There is no combining like terms because none of the like terms are on the same side of the equal sign. Okay, so I'm going to choose to take the y, this minus y, and make it a positive y because remember, I'm jumping this equal sign. So I'm going to take this positive y because what's the opposite of negative? Positive. And I'm going to take it right over here. Okay, so I get 2 plus 1 is 3y plus 8 is equal to 5. I am baking in this room. It is so hot. Okay, so now here's our equal sign. This is positive 8. This is positive 5, right? They're on the opposite sides of the equal sign. So take the opposite of positive 8. What's the opposite of positive 8? Negative 8. Negative 8, right? And that's inverse operating. Okay, so I get 0 here, right? No, so you get 0 there. And I get 3y is equal to negative 3. And now I divide. And I get y is negative 1. Okay, so that's half my system. Now, do you have to solve for x first? No, you can solve for x or y first. It's your preference. Okay, it just so happened that this one was isolated for x first, so that's why we did that. Okay. Okay, so now I go back to step 4, using our y equal number, in this case it's negative 1, substitute it into the either of the two given lines and solve for x. And then once you get the x value, now you have your coordinate point. So that coordinate point is your solution, okay? And then we're going to do a Desmos check as well. Okay, so I get y equal negative 1. Okay, so we're going to go back to our two equations. Which one do you want to use, the first or the last? I'm going to choose the second one. It looks easier. Okay, so I'm going to pick x equal 5 minus y. So I choose, oops, 2 O's. X is equal to 5 minus y. Remember, I am using my y equal negative 1, right? So remember, everything is equal to itself. So look, this is a y, right? Here's a y. And so that's where I'm going to substitute my negative 1. So I get x equal 5 minus a negative 1, right? Because y is negative 1. This happens to be minus y, but that negative 1 is not that negative. That's a subtraction, and then my y is a negative 1. So I put that in, x equal, and then a negative times a negative is a positive, so it's really 5 plus 1, which is 6. So x is equal to 6. Okay, and so now we have our one solution coordinate point, right? And so our coordinate point is xy, always, right? So my one solution, is my coordinate point, 6, negative 1. And there you go. That's what it is. It won't let me. Okay, that doesn't look too cute. Okay, there you go. All right, third example. This is a really long video. I apologize, but I want to give you 3 examples so that I can then assign you the 12 problems and, you know, you have something to reference. Okay, here we go. Third example. We're going to solve the system. Both are in standard form. Notice step 1, it's not done for us. Sad face, we have to do work. Okay, so that means we're going to have to pick a line. We're going to have to pick a variable to isolate, and they have to be in the same line. Okay, so here's my hint. I like to pick the variable, if I can, with the +1 coefficient. It's less work. It's easier for us. We're not dealing with fractions. So I'm going to choose this one right here, the secondary one, the x plus 2y is equal to 6, right? Because what I'm saying is written right there. I'm going to choose this x plus 2y is equal to 6, and I'm going to pick this positive 1x to isolate. And then we're back to that first example. Okay, so here we go. Okay, so I don't have much, by the way, see, there's not much written after. Okay, so here we go. Okay, the lighting is so bad right now. All right, so for x minus 3y. Okay, so this is the one that I'm going to plug into. Okay, this is the line that I'm going to choose, because notice, positive 1x, so much easier to isolate that. So this 2y, I'm just going to inverse operate and make a jump over. Okay, but that I'm going to put right down below so we can look at it. I'm going to take this positive 2y and I'm going to wedge it right in between, but here's my equal sign. So that means I'm going to get x is equal to negative 2y plus 6. And now this is my beautifully isolated equation line where I have my expression where I can now substitute, okay? So remember, this was, whoops, big marker. Okay, I want to isolate x, so I'm going to take the 2y, which is positive, but once you jump the equal sign, you're going to change the sign because it's inverse operating. So I'm going to subtract. Okay, so now here we go. So now you can kind of see both lines here. Okay, everything is equal to itself. So if I have x isolated, x is equal to x, correct? So if I have an x here, and everything is equal to itself, there's my x, right? I just took the second equation and dropped it lower so that I can write. And I can work with it. Okay, so what am I going to put in place of that? This expression. Remember, we're now back to the first example. And I'm going to put that right here, negative 2y plus 6. And that's what I'm going to write. And then you're going to solve it and clean it up. Okay, so what do I get? 4, but in place of x, I'm going to put a parenthesis. And then minus 3y is equal to negative 9. Okay, but in place of x, I isolated my variable, my line, so I'm putting negative 2y plus 6. And now you're back to the first equation where you're going to distribute and clean it up. Combine like terms, right? Inverse operate. Okay, so what do I get? 4 times negative 2, right? We're going to distributive property. 4 times negative 2 is negative 8y. 4 times 6 is positive 24. I'm going to bring down my negative 3y, bring my equal sign down, bring down my negative 9. Okay, so now we're looking for combining like terms. So now we're going to combine like terms. And you have them here. I have minus 8y, minus 3y, and notice here's my equal sign. They are combining like terms because they are on the same side of the equal sign, right? Negative 8y and negative 3y are both on the left side. Okay, so you're going to honor what you see. 8 is negative, 3 is negative. So when they're both negative, meaning they both have the same sign, you add and keep the sign. So 8 and 3 make 11. They're both negative. So negative 11y plus, I thought I messed up for a second. That's 24. I thought that was a y. Okay, equal negative 9. The phone blocks my writing sometimes, so I have to go off memory. Okay, so now here's my equal sign. So now here's a constant, here's a constant. They're separated by an equal sign. 24 is on the left, negative 9 is on the right. That is inverse operating. So now if 24 is positive, I'm going to subtract 24 because I want to jump the equal sign so that I can combine it on the right with the negative 9. So this, right, opposite, so that's 0. So I get negative 11y is equal to negative 33. And now you divide, and this you're very good at. And so y is 3. And so now that you have the first variable, you now just have to solve for the second variable, which means you decide between the two original equations which one do you want to substitute in. Or it could be the one that you isolated. So this is what I'm going to plug in, and now I have 3 lines to choose from. I have either of the two original, or I could even use the one that I actually altered, the second line I altered to isolate my x. And notice y is on the right. It has a -2 coefficient. Then I'm going to add 6 to it, and voila, there's my x. So this is the one I'm going to choose just because it's like so nicely cleaned up. Okay. Okay, so I'm going to choose okay, so I'm going to choose this line. And so now I'm going to go ahead and throw in my y = 3. And remember, everything's equal to itself. So you have y, whoops, and I have a y here. And so I'm going to put that +3 right in here. Okay, so x is equal to -2, 3 plus 6. Well, this gives me -6 plus 6. Those are opposites, so x is equal to 0. And voila, there is our one solution. Oops. And so let me write this. So here's my one solution. It is my solution to the given system, and it is 0, 3. Right. Okay, long video, but I did 3 examples. Okay, so the PDF you're going to see right now, let me just hold it over. Yeah, notice all of my natural sunlight's going away. Okay, I'm going to move this. Okay, so where is it? Okay, let's see if I can, yeah, look, I have a little bit of light. Okay, you're going to have more here, like here's word problems, and it's going to go into elimination. You'll see those videos come up. You're just focused on these 10 right there. And then you'll see the PDF as well. Now, for those of you that want to print this, you're going to end up doing, it's going to be more for your benefit if afterwards you just want to make a collection of all your answers. But obviously, as you can see, a lot of work is required that you're not going to be able to just squeeze all this in, because otherwise I'm not going to be able to read your writing. So you're going to have to do the work on another sheet of paper. But this is it. Okay. Okay, I'm going to shoot another video for the other 2 possibilities, which is no solution because they're parallel. So I have to show you what it looks like, and then infinitely many solutions. So when you're solving, what do you see when you're solving? Because obviously you're not going to get a number because they're not going to intersect. So that'll be the second video. Okay, thank you so much. It's like 34 minutes. Okay, bye-bye.